Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera IB to all panels. My name is Nornazatul Afzainizam, Matric number B05182032. My supervisor is PM Dr. Izamshah bin Abdullah. Today I would like to present to you about my final year project 1 entitled Cutting Perimeter Optimization for Rotary Ultrasonic Assisted Machining of Alumina Ceramic Material. Alumina ceramic has currently been classified as one of the most highly wanted advanced ceramics due to its excellent and outstanding features. Unfortunately, based on Power and others, journal on 2015 state that, like other ceramics, alumina also is classified as a difficult to manufacture material due to its poor thermal and electrical conductivities and also high hardness. Because they rely on the chemical and electrical properties of the process materials, non-traditional processes like chemical machining and electric discharge machining have limitations when it comes to machining ceramic materials. On the other hand, advanced machining processes such as ultrasonic machining USM, laser machining, and water jet machining have the potential to machine alumina ceramic components. Rotary ultrasonic machining RUM is a non-hybrid process that combines the mechanism of diamond grinding and ultrasonic machining. It is capable of working with brittle and hard materials with mechanical, electrical, and thermal properties. RUM can also be used to manufacture components with excellent surface quality and dimensional accuracy while maintaining their physical properties. It is suitable for micro or macro machining of both brittle and non-brittle materials. By first incorporating the ultrasonic frequency to the rotating cutting tool, the vibration oscillation amplitude of the tool is altered, which imposes a static pressure on the workpiece surface grains, where the workpiece surface is then hammered into. Done with introduction, now I will move to problem statement. An edge burr around the bottom of the rod is observable during the cutting process. As when the cutting tool nearly drills through the workpiece, the rod breaks off from the workpiece, causing the edge chipping around the whole exit edge. Edge chipping is generally unacceptable on finished goods and must be machined away by other processes after the RUM service. The greater the thickness of the edge chipping, the greater the overall machining expenses. The statement earlier was stated by Liang Wuxia and others on 2005. Bassem M.A. Abdul and others on 2020 state that the most challenging task reaching the highest MRR while maintaining the lowest levels of surface roughness and edge chipping. In any machining operation, assigning simultaneous optimization of these variables can be a useful development in solving real-world industrial problems. However, poor surface roughness and deep penetrate cracks are the consequence if the machining parameters are not properly controlled. Stated by Lacan or Otto, 2019. Due mainly to excessive tool wear, low surface integrity, and high edge chipping of the machine components, conventional machining processes such as USM are unsuitable for cost-effective alumina ceramic machining. Stated by Al-Ahmar and others on 2018. Among the available contemporary machining methods introduced for processing typical and advanced material, which is ceramic, composite, hard-to-machine materials, and others, rotary ultrasonic machining RUM method has been observed as one of the best suitable candidates which fits for precise processing of alumina ceramic material, as this process produces thermal damage-free profiles along with high accuracy and enhanced material removal rates. Cutting perimeter optimization is an important stage in machining that has been researched by previous researchers. The advantage of RUM can be effectively utilized by optimizing the cutting parameters of alumina ceramic. Besides, the use of alumina ceramic has become more widespread nowadays, showing how important it is to optimize cutting parameter to obtain the perfect output of alumina ceramic. Next, I would like to state the objective of this project. First, to investigate effect cutting parameter of RUM towards machining performance, which is surface roughness, material removal rate, and edge chipping. Second, to know the optimized cutting parameter, which is cutting speed, depth of cut, feed rate of RUM for effectively machining alumina ceramic. Third, to validate the effectiveness of the proposed optimal cutting parameter. Next, I would like to state the scope of this project. First, the machine used is Rotary ultrasonic assisted machining and its focus on cutting parameter of alumina ceramic. Second, find the effect of three major cutting parameters, which is cutting speed, depth of cut, and feed rate, on the machining performance, which is surface roughness, material removal rate, edge shaping, that will give impact on cutting alumina ceramic. Thirdly, output measurement performance focus on highest material removal rate, lowest surface roughness, and lowest edge shaping. So now let's move on to literature review. Here have a few journals. The first journal is from Kajamoy.Ding, an other that was published on 2020. These researches were about micro pockets on alumina bioceramic were done using rotary ultrasonic machining. The findings from this journal are by increased depth of cut and feed rate provides the optimal solution in terms of RUM material removal rate. Here I also include a picture of surface morphology and surface profile at optimal RUM parameters that have been done by these researchers. Next, we turn to the next research. Azram Ramli and several others have made a study in 2017 on an improvement of surface roughness using rotary ultrasonic assisted machining technique for hardened steel material. The surface finish between ultrasonic machining and conventional machining observed, researchers found that a higher cutting speed with lower feed rate can reduce the value of surface roughness. Here I also include a picture of machine surface using RUM that has been done by these researchers. Next up is a journal from Yu Jiao, Bmfu and ZJP published in 2005. They found that the surface roughness becomes lower as the spinal speed increases and the feed rate decreases. Lastly, Bassem M. A. Abdul Aziz Al Tamimi and Ahmad Abul Anas for their journal in 2020 regarding the effect of tool overlapping parameters on the surface roughness, surface morphology, and the profile of the machine pockets. From this research found that the surface roughness decreased with the increasing of tool overlapping percentage. Here I also include a picture of the typical example of surface roughness profile and surface morphology of the pocket machine found in this journal. Next, I will explain more about methodology for my project. The following is a flowchart for my project. This flowchart was done with the result of discussion with my FYP1 supervisor. Initially, I had to choose the cutting parameters. This selection process was done through the past research and found that the three cutting parameters are major parameters that are often done by past researchers. On this project, the HAS machine and FKP were used and the tool used is an mil, while the workpiece measurement are 100 x 50 x 20 mm. Before going to the next slide, here are the alumina ceramic properties. The next main experiments were planned and designed by using a design of experiment technique called as Response Surface Methodology (RSM) through box pattern. For this purpose, statistical software known as Design Expert 9.0 was utilized. The table shows the cutting parameters and range value of the project. The range value has been found based on past research, and then the performance measurement, which is MRR, edge shaping and surface roughness is measured. For edge shaping, image analysis for qualitative analysis using optical microscope. Next, for surface roughness tester were used. Meanwhile, for MRR, this formula will be used to measure it. After that with measurement, Data analysis will be done and ANOVA started to be used to analyze which cutting parameter that give most significant impact throughout the project. After done with ANOVA, we will observe whether the value obtained is the optimal value or not. If not, then we will need to do the machining process again to get the optimal value. This is the expected result after I put the range value of cutting parameter that I stated earlier in the software design expert. For me myself, it is a bit difficult to concept progress and all improvement are due to this online learning. It's the biggest problem. So what I do is, I always contact my supervisor if there's any problem that I can't solve. Overall, the study has gained a deeper knowledge. To fulfill the desired goal of obtaining knowledge, fundamental and an elective source of the study, a variety of approaches are applied. Lastly, the experimental setup for all tests will be carried out using the proper process and apparatus so we can achieve optimum cutting parameter value so we can engrave alumina ceramic. That's all from me. Thank you.